Before we get started on today's video, just want to update you on the app submission thing. As you know from my last video, my app submission to the Microsoft Store failed because I didn't have any screenshots of this, which obviously is not very exciting anyway. So I just emailed them for further clarification and what I could be doing next. So I'll let you know when we hear back. All right, let's talk about today's video. So while I'm waiting on that app submission stuff to be worked out, I decided to keep working on my project a little bit more. And I was just really itching to do some coding because that's what my role is. I'm a developer. So I wanted to prototype what I'm going to be doing to get the temperature from the coolant in the Bronco. As you know, I'm working on the Smart Bronco project. I want to get the coolant temperature to be displayed and also be sent up to the cloud. But the first step is to obviously get that coolant temperature. Now the thing is, I don't want to have a cooking pot right here with 212 degrees water to, simulate the actual temperature of the coolant in the truck and then stick a real sensor in there to draw that out and then do something with it. First of all, it's very dangerous. What I decided to do as a first step to prototype this thing out is to use the Grove starter kit for IoT based on Raspberry Pi. What this does, well, first of all, this is from Seed Studio. Seed Studio makes lots of different things. And one of the set of things that they make, it's more of a platform, is something called Grove. And what Grove is if you have a device like a Raspberry Pi or an Arduino and you don't want to use something like this with a breadboard and pins that go to it, where you have to figure out the voltage and you have to figure out the resistance for every sensor that you buy or every actuator that you buy, they make it simple. So what they do is they create these little pieces of hardware that you can stick on top of your Raspberry Pi or on top of your Arduino, and then you can connect different sensors to it with cables that allow you to just plug and play. Is it too early for holiday blend? So I got this kit a while ago, but I'm going to use it for this project. So what comes in it? First, there's a bunch of sensors and actuators. This is a little rotary dial that can change resistance. This is a distance sensor, an ultrasonic distance sensor. One side sends out a frequency and the other side receives it, and then you can tell how far or close you are to something. A button, you know what a button is. It also comes with this nifty hat. And the hat, what it does is allows you to take all these different sensors and plug it in. And just like with the underlying Raspberry Pi, there's analog inputs and digital inputs. And depending on the type of sensor you have, you might want to use different places to plug it in. So it's just a nice abstraction over the Raspberry Pi, essentially, a hardware abstraction. So what's also really cool about this kit is that not only does it come with the hardware, but there's also plenty of software resources. So for our project, for my project on the Smart Bronco, I'm using C#. And there's a C# library available in the NuGet package feed, which is just a place to get libraries. I can get the Grove Pi, very specific name, using Grove for the Raspberry Pi, C# library. And what I can do with that is I can start interacting in software with these different pieces of hardware. And so I can just basically instead of trying to calculate the temperature from the voltage, I can just get the temperature, thanks to the library abstracting that from me in code, and then going to this piece of hardware and interacting with a specific sensor. So in the code, what I'm doing is I'm gonna get the Raspberry Pi, Grove Pi library, and then start using it to interact with the sensors and then display that on the screen. And you can actually see that right here. You can see the setup where if I were to hold down the temperature sensor, I'm warming it up with my hand, and then you'll see the temperature actually change in the application as it's running. This is the Smart Bronco application. Somehow I get Grove Pi, this hardware, to read the physical temperature in the real world and put it into software. So how does that work? Well, if you right-click the project and you manage NuGet packages, these are the external libraries, and you can see I installed GrovePy. And what this does is it allows me to interact with the physical Grove sensors. Let's start from the front and go back. So I have this temperature sensor text here, and that's what gets displayed on the screen. I have a name, I have some text. Obviously, I'm spelling temperature wrong. Let's fix that. Okay, so display temperature here. So if I look in this, I have a view, and then behind the view, I have the code that basically interacts with the view. So I have this C# right here that interacts with the view. I have my class, and I have my constructor right here, and then my constructor basically creates a sensor from the GrovePy library. So device factory is actually GrovePy device factory. Build a temperature and humidity sensor, which is what I physically have attached to my GrovePy thing. And then I say, okay, here's the pin I want it to connect to. Here is the type of sensor it is. There's several models of sensors that are possible to use. And now that I think about it, I should probably start the timer after I have all the sensor stuff set up. So thanks for playing duck debugging with me. So anyway, once I have my sensor and my service, which I created the service, the coolant service, which is going to do all the things related to coolant. And it takes in a sensor. And the reason why I'm passing this in is because eventually I want to make this testable. And to make it testable, what I would like to do is instead of passing in a sensor that I create here, I can just have dependency injection and say whenever I want a sensor, this is the type of sensor I want to have built. So whenever I initialize this, it'll automatically pass in the correct sensor. And then that also makes it easier for me to test because then I can just kind of use this interface that I want to have pass in and mock it out. And then that way I can say, oh yeah, the sensor is definitely getting 50 degrees and I want it to return a state of cold. And then I'll be able to test that to make sure that if the temperature is 50 degrees, it'll return a state of cold without actually having to have a real sensor, without actually having to really initialize it. And all that stuff is coming up later. But for now, I'm just creating a sensor, passing it into my service, starting a timer. What the timer does is just repeats on a loop every second. What's happening on that loop is I'm reading the temperature from my service. So I have a service.calculate temperature in Fahrenheit, and I'm taking that temperature and showing it in text on the screen. Let's go back over that real quick. Creating a sensor, passing it into my service, starting a timer. Every second, you can tell from here, it calculates the temperature and displays it to the screen. Pretty straightforward. But once you go into the abstraction, there's a little more to it. So as I pass in the sensor, now I have a sensor available to me in the coolant service. This is kind of a long-running or long-lived service, and so I don't want to initialize this a bunch of times. Let's just do it once. So that's why I'm passing it in and putting it as a property here. So we're going to calculate the temperature in Fahrenheit. That's what I'm doing, and I'm returning a coolant model, which is that dumb class that just has properties in it. So I'm initializing a coolant model. This temperature sensor measure just says, okay, let's get the next piece of data from it. Come on, let's go. And then I'm taking that and then I'm rounding it to the nearest two digits because we don't need to have a very, very specific temperature. We can have a pretty generic temperature. So just want to round that down. And then I'm calculating the state. So when I have this running in the Bronco, I actually will want to know if it's cold, normal operating range, or hot. So what I'm doing is I'm not only passing back the temperature, I'm also passing back what that temperature means. Because when I show that on the screen, it'll be really useful to know not only what the temperature is, but if that's normal or not. So how am I calculating that state? Well, I've got a cool little enum here. Enums are neat. And I basically have several states. I like to have one extra state of error just in case, because then I can do something with that if weird things are happening that are unexpected. So basically inside this calculate coolant state, I'm calculating if it's normal, cold, or hot. And if it's between 190 and 220, I say it's normal. If it's lower than 190, it's cold, which is fine as we get started. But here's the kicker. We don't want it to be hot. So if it's over 220, we know it's hot and it's time to shut her down. And this is all
information that is normally displayed in a gauge. Now, not only will I have that displayed in a gauge, I'll be able to see a history of it in the cloud eventually when I get this thing connected to IoT Hub and I start sending information into the cloud. And once I do that, there's a whole bunch of cool things I can do with that information. I could start building models on whether or not it's going to fail soon or not based on historical analysis of the coolant temperature. If I had other Broncos running around that were pulling this information, I could aggregate that information together and see anomalies. So if there's one Bronco that seems to run hot all the time, I could inform that owner that, hey, maybe you should check out your Bronco, bring it in for service because it's running hotter than the rest of them, even though it's not showing any other signs of or issues. There's lots of cool stuff you can do, once we are able to measure the real world and send it to the internet. And this part's just measuring the real world and displaying it locally, but we'll get to the point where we're sending it to the internet here pretty soon.
So that's pretty much how I'm going to be prototyping this. Eventually, I'll want to start mocking the actual input from the Bronco, but I wanted to get the code right before I started messing with the hardware side. So what the Grove starter kit allows me to do is get the code right, get the code in the place I want it to be, and then I can start pulling in actual voltage and measuring it and seeing what shows up, essentially. My initial plan to get real voltage without having a boiling pot of water right beside me is to basically have something create that voltage for me, and then I'll just have the leads running into my test rig, and then we'll go from there. But all that'll be coming up in future episodes, so stay tuned.